Hello Matrix and welcome again. Today we're going to be carrying on with first principles and we're going to do an example that's not as common, but it does come up every fourth or fifth exam. So we do need to know just in case. And that is where you're given x with a negative exponent, or it could be given to you like this, 1 over x. And this is the format that you need to put it in. So if you're given f of x equals x to the minus 1, put it as f of x equals 1 over x. And then we use our normal first principles formula. And so we can put it in, limit as h tends to 0 now. And when you divide by h, so the trick to this one is when you divide by h, that's the same as multiplying by 1 over h. So we're going to just do this, multiply by 1 over h. Now, f of x plus h in this format is going to be 1 over, and then everywhere we see an x, we're going to put an x plus h. So just like we did before, minus, and then the f of x, well, f of x is 1 over x. Okay, so that's the first step. Write it out, but write it as 1 over h. Then what we do is we get a common denominator. Limit as h tends to 0, 1 over h. We're going to say 1 over, and then the common denominator is x plus h. Okay, and then so this now becomes x. And this becomes minus 1 times x plus h. So we're going to do it like that. Okay, now the next step we're going to do is we can simplify this. So we can have 1 over h, and then the x's go away, and we end up with minus h over, and let's times this out, x squared plus xh, limit as h tends to 0. Okay, now what happens is these two cancel. And so we're left with limit as h tends to 0 of negative 1 over x squared plus h. And now we can put in our h as 0. So we don't no longer write h tends to 0. We just substitute in 0 for h. And so this goes away, and we end up with 1 over x squared. And so we can just say that equals. Okay, so for this one, we would also just say f of x, f dash x equals, and we would have to just put in this all the way through. I just didn't have enough space. Do we have time? We can do one more. So let's say that we had f of x equals 1 over x squared. Okay. So again, limit as h tends to 0. I'm not going to write it out again, but you would need to. And so then we would say f dash of x equals 1 over h multiplied by 1 over x plus h squared minus 1 over x squared. Again, we now get it into our lowest common denominator, or sorry, just a common denominator or common multiple. So yeah, common denominator here. So we would have x plus h squared, x squared. Oh, by the way, this answer here is minus because we actually had a minus over here. And so at the top, we're going to have this one will just become then x squared, and we'll say then minus x plus h squared. Okay, now let's times this out. So we can times the top out, leave the bottom as is. So it's going to be 1 over h. I'm going to probably run up. No, I should be okay. X squared minus x squared minus 2xh minus h squared all over the common denominator x plus h times x squared. Okay, and now we are going to, these cancel. And so we are left with, and we can take an h out. And so we end up with h over negative 2x. Let's make it, yeah, we can keep it as negative. And it'll be minus h all over h. And so we see the h's are going to cancel. This bottom we can say, we can keep it as x plus h squared times x squared. Okay, and now these go away. And so we end up with negative 2x minus h all over. Now the h, okay, so we need to write here limit as h tends to 0 on all of these. Oops. Okay, so very important, and I'm going to put it in yellow because it is important. Here we just need to write in all of these. So because I didn't have enough space, limit as h tends to 0 in all of these until we take away the h, which we're going to do next. So here we would say limit as h tends to 0, take that away. And okay, carry on. I'm going to keep this because I'm going to just make the h 0. Okay, now what we can do is make the h 0, and we end up with negative 2x. So now is where we take away the limit as h tends to 0. And so we make h 0, so it becomes minus 0. And this becomes x squared. And then plus 0, so it just becomes x squared. And so we have x squared so this is x plus h squared. Take that away. So this becomes 0, x squared, x plus 0, which will be just x squared, times another x squared. So it's actually x to the 4. Well, I'll do the next one because I need to simplify anyway. And so what we see is one of these x's cancel. And so we're left with negative 2 over x cubed. Okay, so that is 2 examples of doing the first principles using your when you have a negative exponent or you have the x at the bottom. So hopefully that helped. Next time we're going to be doing some more derivative examples, and I will see you again in the next lesson. If this helped you, please find the subscribe button down below, like, share with your friends and all that good stuff, and I will see you soon.